All right, so we have got a situation here where the breakers have been shorting out, carbonizing. So they have gotten hot and carbonized and smoked to the terminals, the bus bars. So it's always good to shut your power off. We're going to inspect these. So this one is bad. So we are going to need to get some fine, like 150 or so grit sandpaper and clean off those terminals that have carbonization on them. So these ones up here, those look fine, but it's these ones down here that are not looking fine. So let's pull things out of here. Shut off your breakers. All right, so how's this one? All right, so it's kind of localized in this area here. It looks like it's that 1, 2, 3 terminals, mostly this one, but also that one. So we are going to clean those up a little bit with some 150 sandpaper and maybe wipe them down with some alcohol. We're not going to put any deox or anything on them because that's not good. Putting the deox on there could cause a fire if these things start arcing and burning. So these are 2 new breakers that we got. Siemens breakers. And so those were holding on okay. But these other ones are all crusted. So I can see these terminals up here look okay. Kill this too and look at those. Oh, no, this here 40 amp is looking questionable too. See here? It's got some burn marks on it, which means this one here probably does. Shit. And then we also have this breaker that will probably... All right, so this one is okay. You can see the side clamps for the bus bar are okay on these breakers. So we're going to have to replace these breakers because, for one thing, these breakers will not fit up. Well, actually, they will. What do you know? Let me grab one of the new ones here. See, these breakers here have a indent, so maybe it will work. Okay, so it will work on one side, but it will not work on the other side. So one of these breakers is going to need... Well, actually, on the 15 amp breaker, it will work on either side, but on the 20 amp breaker, it will only work on one side. That is very odd. You know, I'm not liking these 20 amp breakers that much because the clamp for the bus bar is wider than... So you can see that it does touch. You see, it is touching there. Yeah, so it is making a good solid contact, so I'm not going to worry about it. But you see here, this is a 15, this is a 20, and you can see the difference in the gap on the clamp for the bus bar. Okay, so the 15 amp has indents on either side of the breaker, and the 20 amp only has it on one side, so it makes it a little harder to make it compatible to other things. Okay, anyway, let's get this panel back in working order. But yeah, we're going to have to get some double pole breakers, and they do make a double pole breaker like this, except for it will be a 20, 40, 40, 20, and then they are tied together by a collar or a spring tie or whatever they call it. Anyway, they're set to have the two 40 amperes in the center and the 20 amperes on the outside. And if one pops, if 120 or 140 pops, the other will pop. And then between the 20 and the 40, they're not connected. They don't depend on each other. But the breakers, the 2020 and the 4040, do depend on each other, so if one pops, they both pop, okay? So that's what we're going to do here is get some little bit of sandpaper, shut off the main here, like that, and now it is safe to touch in there, but I haven't yet got my voltage tester, so I better go and grab that. All right, hold on for some more exciting electrical work. Okay, I've got my Klein meter here. I think my battery's about dead. Yeah, my battery's about dead. Dang it. We just have 0.117, almost nothing. Okay. So the main breaker is off. So the bus bars are dead. See that? I'm still alive. Then what else we got going in here? Might as well check and make sure all these grounds are okay. There's always somebody has to do things goofy. Okay. Okay, so this here, technically I don't think that this is the bad breaker. I think it is the other one is the bad breaker. Because this is the one that's showing signs of burning on it. And this one is not showing. This one is showing that it was getting burnt by something else. And this is showing that it was getting burned. Okay? So, and that is a twin 20, so we need to get rid of that. This will go here. Yeah. Okay. So I'm pretty sure we're okay with that breaker. Then, Yeah, where was that one? There should be a single, yeah, there's the single breaker, and that was up top. And this looks okay, so we're going to reuse that. And we're going to get the heel of it in there. So you want to get the heel in the hook, and then we can slide the tab down, and there we go. We've got it. Okay, and you can just barely see everything in between there. Okay, so this is okay. Then the next one. Okay, so just quickly here, I'm going to say that most of these looped contacts, like on these breakers, fail because of they're tricky to install and they get bent during installation. Okay, so kind of the problem is that when you have these breakers like this, you have to you can't just put them in there. This one is going to need another single breaker to make it work. But it has this, and this thing here is okay. You see there's no smoke on it, so I'm going to use this. Oops. Let's get the heel in there where it goes. Okay, there. And did we get it on up here? Okay, can't tell for sure, so let's yank that one. And do I have it? Yes, I've got it. Okay, so we're good. Okay. Then this 30 amp breaker. This all looks good. No sign of smoke in there. Okay, so we're going to put this one back. Get the heel into the clamp. Okay, there's that. And that there. Okay. Then we have this here one, another 30, and these clamps here, those look good too, and those look good. See that? No, it's the next one that we start to get the smoke issue. So we'll put this on, and we got to get the heel of the breaker onto those clamps, or hooks, whatever you want to call it, right there, and then onto the bus. And all right, what do we got going here? Did we get this in there right? Oops, don't want to look at me. So those are in, but these should be farther up and forward. Okay. So see the red tape on the white wire signifies that it is a second hot, which would normally be red if you were using 12.3 wire, but we're using 12.2, or they used 12.2. So you don't have a neutral, you have two hots. So you just put red tape on the second one, the white one, to signify that it is a hot wire. Okay, then our next breaker is this one. And I am classifying okay. That's a 60 amp one, and okay, so I am calling this good in that it's not this breaker that was bad, but the breaker that was on the other side of it. And so yeah, we'll figure that out in a minute. So let me, I gotta put the phone down and work on these other breakers. I have to think here, and I can't do that with the phone running. Okay, so with closer inspection here, you see how this tab is melted away, and you can see that some of the bakelite in the breaker is also melted away. So this breaker is toast. And let's take a look here. This one here, I mean, it should be okay. I don't see a problem with it. This, I believe, is just smoke from the breakers next to it. So I'm not going to worry about this one. And these ones here were all okay. And these ones here are okay. So all we have to do is we need to get we're going to need to get a double, a 4-position, a 20, 40, 40, 20. Breaker. Looks just like that. Okay, but you see here, right there. See that?
Yeah.
And then you see how this is here is burnt out, liquefied there too.
Yeah. Let me get unloaded. I gotta bring in a whole bunch of stuff.
Yeah. All right. Okay, so this is what we're going to do. We are going to remove this old style of double pole breaker. You see it's a small, skinny one, and these small, skinny packages are subject to excess heat. So what we're going to do is put in a full-size double pole breaker because we have the space. And one thing nice about the full-size breakers is you see it has this air gap between. So this will stay cooler functioning than the little tiny double pole breakers will. See, there's no air going in between these, and the hooks on them, it's just not a good connection system. Okay, so let's swap these out. We're gonna take out these 20 amp, these large 20 amp, stupid camera. We're gonna take out those little twin pack 20s and put in these full size double pole breakers. Okay, so they just slide in like that, come over and pop right on. Tight fit, okay? So that's what we're gonna do. Okay, so if you look at the old style breaker there, this here is a 240 volt version, and what we have is the this section here goes between the tabs or the blades on the bus bars. You've got the bus bar that runs down the panel, and then you have a blade that sticks up and the breaker mounts onto that. But on this particular breaker, that is not where the blade goes. The blade goes on here and on here, and that is how they get 240 volts on a small twin breaker like that. And then the breaker also has a clip between, or a joining device between the two halves of the breaker, so that if one pops off, the other pops off with it. Okay, so the other thing is that if you look at the design of this, it's just a long piece of flat wire that is hooking over the blade on the bus bar. And the problem is that it does not exert very much pressure on the blade, because it just comes up, bends over. So this side here really does not generate very much contact pressure against the bus bar blade. This side here generates a little more pressure, but because this is loose, that is also going to be loose. So it's just not a good design. And breakers like that, I'd consider replacing them if you have them in your house. The fact, or the nature of electrical, is that once it's in and working, it should continue to work until you mess with it. So as long as you don't do anything with it, it should keep on going the way it is, pending no failure of the breaker device itself or some other issue. But otherwise, without any outside interference in the system, it should continue to do what it is doing. Okay, so now what we have here is a double breaker. Now this here is the 20-40-40-20 breaker that I told you about before. So if you look at it, you see right here that metal piece that connects the two 40s together, and that is called a handle tie. And on some breakers, the Siemens breakers like these don't have the other handle tie, but Eaton makes a breaker that has a long bar that goes down across and connects here, and when one goes, they both go, just like on this one here. If one goes, they both go. So the handle tie on a 240 volt circuit is very important, because if one side of that circuit has an issue, you do want to pop both breakers and completely cut the circuit off. Okay, so another thing about these breakers is these particular breakers will not work on this panel. And the reason is that they have this metal piece that is preventing the insertion of the blade on the bus bar. And this here's another. This is a 2020 breaker, and you see that one also has the metal piece that is preventing the insertion into the breaker box. So here is the single breaker, and you can see that this has no metal piece preventing the insertion into the blade type of breaker connection. Okay, now this is the 20 amp version of the same type of breaker from Siemens, and this one here also does not have that 20 amp or that piece of metal in here preventing the insertion. You'll notice that on the 15 amp breaker, the clamp that goes onto the blade of the bus bar is a tighter fit, and there is a looser fit on the 20 amp version. So you see them there. And then also the connection for the wires is a little bit different on it too. This one here is the 20 amp. And that's the way that the wires are connecting through that. And here is the 15 amp. So it just has a little bit different of a way to clamp the wires into the breaker. Okay, so that is one of the main things that you have to look for when you are looking for a breaker that will work in a different brand of electrical panel. So these ones here, those won't work, but these ones here will work. And I think that these are like a 20C, and these are a 20 ULC or something. So that's just one of the things you have to look for, is if they will fit into your breaker panel. And this is just one type. There are several different ways that manufacturers have figured out to keep their panels brand specific rather than able to be swapped out with other brands. Okay, and another one you want to do too when you're looking for an alternate breaker is, one, ask the people at the parts counter, if there is one, to get a compatible breaker for the electrical panel that you have. And the other one is to take the breaker that is in the panel to the store and compare it. Put it right up next to another breaker and make sure that all of the fitting pieces are the same. So you see the face of the breakers here are the same, and the hook of the breakers is all the same down there. And the connection for the breaker up here is usually where the critical area is. Okay, so that is it. And these ones here are all going to be returned because I could not get the connection plan that I wanted using these breakers, and that's why I went to the full-size breakers, which, let me bring the camera or the video to that. Okay, so we see that, and let me just kind of move along here. Okay. So there you go. Well, I don't know. I'm not sure what I'm looking for, so. Okay, so that is it with the getting alternate breakers for your panel. This is a Challenger panel, and the Siemens. Okay, so the installation is done, and we put in a new 40, 20, 20, 20, and these are all the full-sized double pole breakers. And as I said earlier, they have an airspace between them, so these will stay cooler, and unlike the twin packs like these, they won't get so hot. So everything is going good here. We have a single spare wire here, and there are 2 positions remaining that can be 4 more circuits added if you need them, and actually several more circuits if you go back to the double up breakers here. So anyway, you can see we have clean wire breaker connections, those clamp points there. And one of the things that we did run into is that these 2 wires here, we have them tagged and noted and tied together. But the problem with those is they are supposed to be 2 separate circuits, but they are somehow interconnected, and it's either through the neutral or through the hot at some location out there somewhere. That's just one of the things that happens over the years when homeowners and inexperienced people attempt to do wiring. So anyway, what did happen is we assumed, when we put this all back together, we just assumed that everything was proper. That is the nature of electrical, is that once it is working, it will continue working until you mess with it. So if it's working, don't mess with it, because it will continue to work, pending no breaker failures or short circuits or some catastrophic event. Wiring just continues to do what it does if you use it correctly. So what happened, though, is these 2 wires were on separate bus bars. So one was on that bus and one was on this bus. And between these 2 buses is 240 volts. So when I turned on the breakers, I got a big blast out of the main breaker, and the main popped off. So then I got out my meter and started testing, and I discovered that these 2 wires are related somehow, somewhere. So as long as they are connected to the same bus bar, then it's not a problem. But if you put the one wire on another bus bar, then you're going to get 240 volts. And just so you understand, from here to here is 240 volts. And with these 2 wires, they're both connected to that, which is 120 volts. But the difference between them is 0, because they are both connected to the same 120 volts. So there's no problem, it's just 120 volts. And as long as we don't connect it to the other bus bar, we won't get that lovely 240 volt surprise. Okay, so that is it. We will explore some of the wiring in the house and try to figure out what is going on with that. But until then, everything is fine, everything is safe. And as I say, we removed all of these old style breakers, you see how they have the heat problem going on here. Here's a good example there. So you can see that they were not working well, and the homeowner heard seriously loud buzzing and arcing going on, and it could very well have been this breaker here. You can see how the metal is burnt off on that tab there, that cleat that connects to the bus bar, and the cleat on this side is fine, but that one is in serious doo-doo shape. It's all carbonized, and when you get carbon buildup on your parts, that equals resistance, and resistance equals heat, and heat equals fire. So there you go. Okay, that's it for now, and if there are any updates, I will bring them to you. Okay, this is the electrical panel as when I opened it up, and it was arcing and sizzling and making noise in there. Took out some breakers, and you can see that there was some smoke and some action, carbonization, heat had been developing in there, and it was a fire hazard in the making. So there is one of the worst breakers. You can see how the heat had burnt the metal in there. And this is the panel after we replaced all the breakers, putting in the large double pole breakers and new Siemens breakers, replacing everything. And that's just the same picture, just zoomed in a little bit. So thank you for watching the video. I hope you enjoyed it, and I would say that you have probably learned something if you watched it this far. Thank you for your patience. It takes time to convey knowledge. And I will see you on the next video. Thank you again. See you next time.